Back again. So I'm starting with number 11 from the Math 107 Test 3 review. Number 11 says the average teacher salary in New Jersey is $52,174. That's our population mean mu. Suppose the distribution is normal with a standard deviation of 7,500. That's sigma. So 11a. What is the probability that a randomly selected teacher, one teacher, makes less than $50,000? So this is an X value because we're only talking about one teacher in a year. So let's draw the picture. Middle is our population mean, 52,174. Our data value X, 50,000, is less than that, so we're going to go over here to the left and place it there. And then it said less than 50,000, so that means we shade to the left. So we're going to convert that data value X into a z-score. That's the shorter z formula because we're only converting a data value X into a z-score. So we're going to take X, 50,000, minus mu, 52,174, over sigma, 7,500. So this is going to give you negative 2,174 over 7,500. So putting that in our friend, the calculator, that's going to give you negative 2.8, negative 0.289. So negative 0.289 makes that negative 0.29 as our z-score. So we are going to go to the negative z table, and we're going to look up a z-score of negative 0.29. So row negative 0.2, and then 9/100ths is the very first entry. We have that area 0.3859. That is the area to the left, 0.3859. That's what we wanted, the area to the left, so that's my answer, 0.3859. So for 11b, it says, if we sample 100 teacher salaries, so now we have a sample size of 100, a large sample, from a normally distributed population. What is the probability that the sample mean is less than 50,000? So now this is X bar, less than 50,000. So now we have to use the longer z formula, X bar minus mu over sigma over the square root of n, to calculate that. So again, let me draw the picture. In the middle is our population mean mu, 52,174. So now we're saying a sample size of 100, what's the probability that that sample mean is less than 50,000? So again, it's to the left of the mean, but it's going to be a lot farther to the left. In a large sample of size 100, it is not likely that the mean of that large sample from a normally distributed population would be so far from the mean, even though it's not that far away. So it's going to be a lot smaller number than that 39% we got from part A for the probability of one person's salary being less. There's a lot of variability between an individual and the population mean. There's less variability between the mean of a large sample and the mean of the population. So this should be a lot less, this probability. All right, so now we're going to go to finish 11b. So we are going to calculate the z-score using the longer z formula. So X bar, 50,000, minus mu, 52,174, over sigma was 7,500, over the square root of n, 100. So this is negative 2,174 over 7,500 over, you know what, the square root of 100 is 10. We can do that. And remember, normally we're going to put in parentheses here, which you could do, but you know what, this actually divides evenly, so I'd make it easier on yourself for doing the calculations. Negative 2,174, we would divide this next anyway because of the parentheses. So that's going to be divided by 750, 7,500 divided by 10. So that's, let's put that in your calculator. So 2174 negative divided by 750 is going to give you negative 2.898. So we're going to round that and call that negative 2.90. That's very unlikely to happen, to be almost 3 standard deviations from the mean here. So negative 2.898. So we're going to call that negative 2.90. And we're going to look that up on the negative z side of the table. Negative 2.90. So row negative 2.9. And then going down here to 0 hundredths gives you 0.0019. And that again is the area to the left. So let me pull my chart back here. So 0.0019. That's the area to the left. That's our answer. So the probability that you would take a large sample of 100 teachers and have their mean salary be less than 50,000, very unlikely. That's less than 1%. That's like 0.2%. It's very unlikely to happen. All right, so going to number 12. Number 12 says, assume that the systolic blood pressure of adults, normal adults, is 120 millimeters of mercury, so that's mu, 120. And the standard deviation is 5.6, there's sigma. Assume the variable is normally distributed. So A, if an individual is selected, find the probability the individual's pressure will be between 120, so X value 120, and 121.8. So we got two X values. So let me draw the picture. Population mean mu in the middle of 120, which is also the first X value. That's a little bit helpful. And then 121.8 is bigger, so you're to the right of the mean. And it says between. So I'm going to shade between. So we could convert 120 into a z-score, but we're at the mean. So we know that at the mean, the z-score is going to be 0. You could calculate it, but it's going to be 0. So, or 0.00. And if we look that up, we get the area to the left, but we also know that the area to the left is 50% or 0.5, or you can look up 0.00, and you're going to get the area to the left. So the one we really need to calculate with the shorter z formula, because we're only converting a data value x into a z-score, is x 121.8 minus mu 120 over the standard deviation 5.6. So this gives you 1.8 over 5.6. So going to our calculator, we're going to get 0.321, 0.32, because after the 2 is a 1. So we're going to look that up on our positive z side of the table, 0.32. So row 0.3 and then 2 hundredths, which gives you 0.6255. Now that is the area to the left. All of this area is 0.6255. But we don't want all of it. We only want the shaded part. So we have to take away the left side that's unshaded. So we're going to take 0.6255, subtracting the unshaded left tail of 0.5000, which is going to give us our answer of 0.1255. So the probability that a randomly selected adult would have a blood pressure between 120, which is the mean, and 121.8, which is pretty close, right, is about 12-13%. So now we're going to go to question B for 12, and it says if you sample 30 adults, so this is a large sample of size 30, n, find the probability the sample mean will be between 120, so now x bar 120, and 121.8. So again, let me draw the picture. Population mean in the middle at 120. Oh, not 0, sorry, 120. And then we're going to take x bar 121.8, which is probably going to be a little bit farther away here, or maybe a lot. What's important is to the right, and we're shading between. So 120 again is the mean. The z-score is going to be 0. You could put it in the longer z formula because we're converting a sample mean x bar into a z-score. So you take x bar 120 minus the mean 120 over the standard deviation, which was 5.6, over the square root of the sample size 30, but that's just going to give you 0. 0 divided by anything is 0, or 0.00. So again, let me move this up so you can see it. So if I look up my z-score of 0, or 0.00, I'm going to get the area to the left, which I know is 50%, 0.5000. So I'm putting that here. Now I'm going to convert 121.8 x bar into a z-score, again using the longer z formula. So x bar 121.8 minus mu 120 over sigma 5.6 over the square root of the sample size 30. So this is going to give you 1.8 over 5.6 over the square root of 30. Square root of 30 doesn't come out evenly, so you got to use parentheses in your calculator. If you have trouble making this work, find the square root of 30 in your calculator, which is about 5.4772. Carry 4 or 5 decimal places, put that in, but you got to use the parentheses here. So 1.8 divided by, left parentheses, 5.6 divided by the square root of 30, right parentheses, equals, gives me a z-score of 1.760. So I'm going to call that 1.76. And let me just double check my calculations. Okay, so I'm going to look up 1.76 on my positive z side of the table here. Row 1.7 and then 600ths, which is going to give you 0.9608. Again, that is the area to the left, 0.9608. So of this area, 0.9608, I want to take away the unshaded left tail of 0.5000 or 0.5, which is going to give you my answer, 0.4608. So that is probably that if you selected a large sample of size 30, the mean blood pressure of that sample would fall between 120, the mean, and not very far away, 121.8. Because again, the mean of a large sample should not be very far away from the population mean. So I'm going to stop here and I'm going to go to the next video to do starting with number 13.